Hello, Shruti, Anthony. Hi, Darjan, Indu. Welcome. This is your captain, your physics master teacher, Shreyas, and I'm going live from Bangalore. And welcome to the one-shot session of Ray Optics. And today we're going to do some really amazing stuff with theory, with concepts, with formulas, and also, of course, the problems. So all of this in this Zero to Superhero series for all the JEE as well as NEET aspirants. And this will also help you for your KVPY CUET board preparation. So when I started this Zero to Superhero series, I kept in mind that your term 2 exams are around the corner. So our primary focus right now is on term 2, and this would be the last class before your board exams on Zero to Hero series. After your boards, I will continue this series and I will cover up all the other major topics of term 1 as well as the 11th standard. Alright, so now we are going to focus more towards term 2 and other exams like KVPY, and also for the 11th standard I'm going to do some more series in the days to come. But remember, Zero to Superhero series will continue, so don't get scared, and I will complete it well in advance before your JEE as well as your NEET exam. I hope this thing is clear. Hi Sri Krishna and Anthony, I'm very good. I'm not sure about that. Hi White Devil, good evening. And those of you who do not know me, my name is Shreyas and I'm your physics master teacher, and I have been producing ranks for a long time, and I'm here on YouTube to make sure my learnings, my teachings spread all over the country, and that too in English medium, because you guys always wanted to learn in English because you're studying in English medium too. So you can get to know more about me from my Instagram handle as well. Go ahead and check it out. Good evening Kavya, Sri, Antara. I hope you guys are doing great, and don't be nervous. I know this is a time where most students get tensed, the minds get blocked, and you don't know what to do. Just follow my lead, see whatever I am doing. My complete focus is on your term 2, your JEE, your NEET, your CUET, KVPY, BITSAT, all these exams. It's there in my mind. Don't worry about it. It's all going to be sorted. Whatever I do similar things at home. Practice mock tests, do your revision, revise your formulas, keep solving problems. That's all you need to do. So in today's class, we are going to do everything about prisms, dispersions, combination of prisms, obviously your human eye and the least distance distinct vision, your simple microscope, compound microscope, and obviously telescope as well. The session is focused on the application part, the conceptual part, and all the important pointers that you should know regarding this chapter. It's a one-shot session, roughly 1.5 hours, max 2 hours. Alright, so let's begin, and I hope you have smashed the like button. Hello Pooja, nice to see you. Hi Pavan Sai, Sri Ram, welcome Kanan, and I can see a lot of you are new to the channel as well, so do not forget to hit the like as well as the subscribe button. Thank you Medico Goal, I'm so glad, and I'm pretty sure if you continue watching the rest of the series, you will be even super duper confident, and that's what the name stands for, Superhero series. So don't worry, you will definitely become a hero and a superhero too. Josna, good evening. Hi Indian Game Up. So let's begin with the class, and in case you have not joined the Telegram channel, make sure you join it. And guys, the NEET students especially, remember there is a Ekalavya batch test which is going to happen very soon. The Ekalavya batch is the special batch for all the students who are like-minded and who have performed and done through their basics, and their performance is up to the mark, and then you need that final push to boost your score. Sometimes it happens you get 500 or 550 marks, but you don't know how to improve it to 600, 700 marks. So this Ekalavya batch is exactly for all those students who want to boost their performance, and their fundamentals are at least good till a basic level. So complete revision of 11, 12, test series, mock tests, obviously your assignments, discussions, all the classes will be provided with the doubt solving, with the best of the best team. All the material, assignments, question bank, everything will be provided, and this is a free batch. So make sure you give the entrance test and make sure that you join the batch ASAP and use the link which is there in the description box. Tomorrow I'll be conducting a special session for all the NEET students with Vipul Arora sir, who is heading the NEET division for all the toppers batch. So let's get started with prisms as well. Reshma, good evening Bacha. Will there be PYQs? So PYQs are there in a very different form. Since this session is focused on Zero to Superhero, so I have not kept too many PYQs, but conceptual questions which are similar to the PYQs. you will see similar questions have come in NEET or even in JEE. Good evening, Ajay. So let's begin. Good evening, Bhattacharya. Now, whenever I talk about prism, many students think that prism means it should be triangular. That's not true. Prism means it could be any two faces which are at an angle to each other, and the rays which enter the face. Let's say a ray enters here. Okay, just hold on. Let me just get my pen out here. All right. So let's say a ray enters here. It refracts at this point. Then it exits out here. It refracts at this point. Same thing. If a ray enters here, it refracts and again it refracts. So basically, two refractions should occur from the opposite faces. Okay, or one after the other. But the faces should be at an angle with respect to each other. Then it is a prism. And this angle is called as the angle. It's called as the angle of the prism. Over here, also if you extend these two faces and if you see that they meet somewhere, even this is called as the angle of the prism. The only difference between a prism and a slab is that in a glass slab, you will notice that the faces are parallel to each other. Because the faces are parallel to each other, what's the difference that you get? Boards also Indian gamers. Yes, a gamer. Boards will be also focused in the NEET Ekalavya, even the JEE Ekalavya batch. They all focus on boards as well. JEE mains, everything. You get all complete, preparation. It's a complete comprehensive package. So the difference is that when a ray enters, it refracts. It also refracts, but the final ray, the emergent ray, is parallel. Yes, the final deviation is zero. The incident and the final ray, they are parallel. But if you notice, this emergent ray and this incident ray, emergent ray, incident ray, they are not necessarily parallel out here. So they can deviate. So that's one fundamental difference between a slab refraction and a prism refraction. And if you guys are clear about this, go let me know. And yes, do not forget to hit the like button as well. Now, what are the different things, the angles that you need to know regarding prism? Let's talk about it. Also, let's get to know the relationship between them. Hello Dhanush, good evening Bachalo. First of all, if you notice, the incident ray refracts and then again refracts. This final angle through which it comes out, made with the normal, is called as the emergence or emergent angle or angle of emergence. This is your emergent ray. This is your incident ray. Usually this is called E, or even you can call it as I2, and usually this is called as I1, the angle of incidence. Why is it called I2? Is because of reversibility of light. So basically, using reversibility principle, the incident ray and the emergent ray can be interchanged by changing the direction of the light. Meaning, if the light comes from here, then this will be the angle of incidence, and finally this will be the angle of this will be the angle of emergence. So it's retraceable by reversing the direction of the rays, right? Right follows reversibility principle. Thank you, Roshant. All right, very good, Sriram, very good, Noshin. Good evening, Bachalo. Now, the angles which are there inside, these angles, this angle, since this is I1, this is called R1. Since this is I2, this is usually called R2. Obviously, this one I just told you, this is called as the angle of prism. All right, this is something which you should know. Now, there is a relationship between R1, R2 and A. The first relationship that you should know is R1 plus R2 is equal to the angle of prism. This is the first relationship. Everybody should know. Yep, very, very important, guys. Yep. So, okay, we are going to see combination of prisms, Pawan Sai. All right, we're going to see that. So this is something which you should know. All right, moving ahead to the next question and next concept. But before that, remember Snell's law can be applied. If you want to solve some problems, Snell's law is still applicable, meaning you can just write mu is equal to sine of I1 by sine of R1, which is also sine of I2 divided by sine of R2. Remember I1, sine of I1 by sine of R1, or sine of angle of incidence by sine of angle of refraction. Snell's law obviously is valid. Sometimes you are going to need this equation as well. Now, the incident ray obviously is not parallel to the final ray. they both make certain angle, it deviates. Like for example, you are walking on the road, okay, or you are walking in the market, and then suddenly you see your strict teacher from school. Then what will happen? You will change your direction, right? You will change your direction suddenly. You deviate. So this ray also deviates. He saw a strict teacher, he deviated. And this angle is called as the angle of deviation. This was your intended path, but your actual path has shifted by some angle. That angle of deviation is incident angle plus emergent angle minus the angle of prism. This is what it is. You should know this formula. Alright, this is something which is very, very important. You should definitely know this formula. Okay, everybody clear till this point? Do let me know. What is I1? Incident angle. What is I2? Emergent angle. What is this? Angle of prism. Delta, the deviation. Perfect. Shall we move ahead, guys, to the next point? Clear. Amazing. Now, this angle of deviation, like you can see, depends on I, incident angle and the refractive index and all of that. So if you change the angle of incidence, the final ray also comes out at different angles, but there is one particular angle for which the ray deviates the least, hardly any deviation. So that's the minimum angle of deviation. Okay, so now if you are talking about the minimum angle of deviation, remember, then the rays which enter in and exit out are very much symmetric to the prism. I'll tell you what it means. If you plot the graph of deviation versus the incident angle, so what have you done? You have plotted the graph of delta versus I. So on the next slide, this versus this, delta versus I1 on next slide. You will notice the graph comes out to be something like this. There are two angles for which you get the same deviation, but there is only one angle for which you get one unique deviation, and that's the minimum deviation. And that happens when you can see the refracted ray inside the prism becomes symmetric, meaning whatever angle it is making here, it will make the same angle here. Whatever angle it is making here, it will make the same angle here. It's completely symmetric. If you reverse the direction, you will see it goes exactly with the same angles. If this was 30, this will be 30. If this was 50 degrees, this will be 50 degrees. So it's completely symmetric in nature. So this happens basically at nothing but I1 is equal to I2. Incident is equal to the emergent. This is what you should definitely know. And when that happens, you can use your formula for delta, which I've just given to you right over here. Delta is I1 plus I2 minus A. Since incident and emergent both are equal, this will become 2 times. Hence, delta will become 2 times angle of incidence minus A. Okay, so it is a natural byproduct of the previous relation and this relationship. I hope this is clear. The final expression which you should know is angles between of the prism, the deviation angle are related to the refractive index at minimum deviation, and for minimum deviation you will see the relationship which holds true is mu is equal to sine of angle of prism plus minimum deviation. This is only for minimum deviation, please remember, not for any other angle, divided by sine of angle of prism divided by 2. Very, very important relationship. So if you are given the refractive index and the angle of prism, you can immediately find the minimum deviation. If you know the minimum deviation, you can immediately find the angle of incidence. So all the parameters are related over here. Okay. Oh, is it Shruti? I will make sure that it is added in the description box. Definitely, I'll help you out with that. Okay. Yes, Anthony. It does change if the convex lens material is same, but you have changed the light color. Yes. If red color, violet color, blue color is used, yes, they have different refractive indices. We'll be seeing that today as well. All right, guys, there is one interesting thing regarding thin prism. Now, what is a thin prism? Thin prism is a prism whose angle is very small. Whose angle, the apex angle or the angle of prism is very small. And because the angle is very small, it also means sine of angle of prism is roughly the angle itself and the cos of the angle of prism is roughly 1, and this is also roughly the tan of the angle. This is your small angle approximation. Also, when the angle of prism is small, you will notice this graph will not be so curved. This is a graph for, when angle of prism is basically large. An angle of prism is large. But when angle of prism is small, you will notice that the graph is hardly like this. So this is when A is basically small. So for all the angles, you will notice, for all the angles of incidence, you will notice that the deviation is roughly the same. The deviation is roughly the same. Approximately, yes, Sri Krishna. It's a very, very interesting and important concept. Hi Daya, hi Maxi, thank you so much. Hello Ankit, welcome back. Nice to see, guys. I get very happy when I see all my regular students out here every day learning from me. Trust me, there is no more joy than seeing all my students every day learning new concepts, or even if you're not learning, maybe revising and seeing new problems. Nice to see all of you guys out here. Okay. Now, in the case of angle of prism being very small, and you use this relationship, because sine of a small angle is the angle, sine of a small angle is the angle. From this relationship, I'll just put a star mark here. I'll just go back. I'll just put a block over this relationship. Very, very important. So, using the small angle approximation, what do you get? The delta minimum, which is also roughly the delta for all angles. Why is it the delta for all the angles? I just told you in this slide that the angle of prism being small, it is roughly the same. The deviation is not going to change much. Then that formula comes out to be A into mu minus 1. Very, very important formula again for small or thin prisms. Angle of prism into mu minus 1. Alright. Yes, this graph is very important. This has come as a PYQ in JEE and many other competitive exams. Okay, just draw the graph, choose the graph. 4 options were given, and imagine such a fact-based direct questions have come in the competitive exams. Alright, is everybody clear? Okay, one doubt I have. Let's see if you can answer this. Should this A be only in radian? Imagine this delta is in radian, this is in radian. If this is in degree, this is in degree. Is degree allowed? If I use delta in degree, angle of prism in degree, is that allowed, guys? Let me know in the chat box. What do you guys think? Is only radian allowed over here, or degree is also okay? Yes, this is the last session of this chapter, Chan. 2 lectures. Big chapters I have taken 2 classes. Small chapters, okay, I have combined, or I have taken 1 class, because yes, I have given adequate time of at least 1.5 hours or 2 hours. Yes, you can use both degrees or radians, it works. Yeah, it does not matter, because if you use degree here also use degree, it gets cancelled, so units are same on both sides. But make sure you use the same units on both sides. That's the catch. See, while doing or making this approximation, then the angle should be in radians, but finally when you convert it into degrees, doesn't matter if delta is also in degrees. If both LHS and RHS are in the same unit, it doesn't matter. It anyways gets cancelled. Alright. Okay, I hope this is clear. Some of you thought that only radians is allowed. Alright. Okay. So moving on to some questions. Remember, concept, questions. That's the flow of today's class. So get ready for some amazing, simple, conceptual questions which will build your confidence in this chapter. And then after the class, make sure you solve the exercises, solve the assignments from the crash course, make use of HC Verma, solve PYQs, and then get enough practice so that you actually become a superhero. Okay, just don't stop where the class ends. The path of the refracted ray of light in a prism is parallel to the base of the prism. When light is of a particular wavelength only, ray is incident. Normally, ray undergoes minimum deviation. The prism is made of a particular type of glass. What do you guys think about this? Yep. Wave optics, I think I have taken 2 classes as well. Yes. Yeah, I have taken. It's already there. L1, L2, both are there. I have already completed wave optics Chan. Alright. Long time back. Yep. Very good. Proud of you, warriors. Very good, Roshant, Gokul. Amazing, Daljan. So, if it is parallel, what does it mean? See, this is your prism, this is your prism, and your light rays are parallel to the base inside the prism, and this can happen only under one circumstance: if this angle is equal to this angle, and when this ray is parallel to this ray, it is basically minimum delta. Yep. So it's symmetric. I just told you some time back, only when I1 is equal to I2, right over here, I1 is equal to I2, so it is parallel. Okay. So moving on to the next question. 60 degrees is the angle of prism. Refractive index is √2. The angle of incidence for minimum deviation is how much? Let's try to figure this out. The angle of deviation for the angle of incidence for minimum deviation is basically how much? I think we should start by drawing a diagram so that we get some idea what exactly is happening. The angle of prism is 60 degree. So here I should put 60 degrees. All right. So then let me draw the ray. Minimum deviation, that means the ray is parallel to the base inside the prism. Let me also draw a normal to the face. Okay, over here as well as here. Remember, this angle and this angle both are equal. This is R1, this is R2, because it's parallel to the base for minimum deviation. This is how the ray enters in. This is your I1 and this is your I2. And remember, I2 is also equal to I1 because it is again minimum deviation. Now, I had just given you a relationship some time back. Recollect that. R1 plus R2 is equal to angle of prism. R1 and R2 both are equal because it's minimum deviation. So twice R1 is equal to angle of prism. Therefore, twice R1 is angle of prism, which is 60 degrees. So naturally, R1 is nothing but 30 degrees. R1 is nothing but 30 degrees. I am very good, Rupali. Welcome aboard. Now, the next point is, we don't have to find R1, we have to find incident angle. I had also mentioned the fact over here. Look at this. Oops, where did we go? Oh my God. Where did we go? Yes. Over here, that Snell's law is applicable even for this surface or this surface. It's a normal surface. Light is changing the medium. So you can use, your Snell's law. So let's use our Snell's law and notice what we get. So sine of I1 divided by sine of R1 is equal to mu. Therefore, sine of I1 is mu. Mu is √2. I will take R1 on this side, sine R1. So it will be sine of R1, which is 30 degrees. So that's going to be √2 into half, which is nothing but 1 by √2. Of course, I1 has to be. Whose sine is 1 by √2? It is 45 degrees. Do I have such an option? Yes, option A is correct. Perfect, White Devil. Hi, Nilarjan, welcome. Hello, Falcon. I'm very good. Yes. Hi, Navyathija. I'm very good. You are live in AI Live. Yes, that's the whole beauty of AI Live. All right. Is that clear, Machalo? Is that understood, my warriors? Hello, Manu Sankar. So all we have done is made use of geometry, that the base is parallel to the ray inside, and the formulas R1 plus R2 and the Snell's law. Nothing more, nothing less. Let's move to the next question coming up on your screen. Very good. So a prism having refractive index 1.414, well, 1.414 is nothing but √2, and refracting angle 30. So when they say refracting angle, okay, let's start writing down what and all is given. This means mu is √2. Refracting angle also means angle of prism. So angle of prism is 30 degree. Has one of the surfaces silvered. A beam of light incident on the other surface retraces the same path if the angle of incidence is. Okay, let's again start with our diagram. Without diagram, things are not so clear. One of the surfaces silvered. This angle over here is 30 degrees, and the ray of light after hitting the second surface retraces the path. If something has to retrace the path, obviously it can't be incident at an angle. It has to fall perpendicular to the surface so that it comes back along the same path. Imagine this, if you throw the ball at an angle, it deviates. But if you throw the ball at the 90 degrees, then it will come back at the same, in the same path, just the direction will be opposite. So it has to be incident normally, that is very obvious, so that it retraces the same path. Now over here, I can draw the normal. So you can see that this is your first angle of refraction, and this of course will be your angle of incidence. So the light ray goes inside like this and comes back along the same path. Alright, now it's just a matter of marking other angles and figuring it out. So the question is, what is the angle of incidence? So I1 is how much? If you want to find I1 and refractive index is given, I think I need to know R1. Now to find R1, make use of geometry. I1 has to be found, refractive index is given. So I think you need to use Snell's law to find I1 by finding R1. How to find R1? Look at this triangle. This is 90, this is 30. Obviously, how much is this angle? Come on, my warriors. How much is this angle? Obviously, this is going to be nothing but 60 degrees. If this is 60 degrees, how much is R1 going to be? How much is R1 going to be? Because the total angle is 90. So it will be 90 minus 60, which is nothing but 30 degrees. So I found R1. I just need to find I1 by using Snell's law. So essentially, sine of I1 by sine of R1 is nothing but mu. So sine of I1, sine of R1 is nothing but sine of 30 is equal to mu, which is nothing but root 2. Therefore, sine of I1 will be root 2 times sine 30 is nothing but half. So this will just become 1 by root 2. Whose sine is 1 by root 2? It is nothing but 45 degrees. Hence, the correct answer to this question is going to be 45 degrees. Perfecto! Amazingo! Very good, White Devil. Very good, Roshant. Very good, excellent, Pooja. Nice, keep it up, keep it up. I feel very happy when you put your answers in the chat box. Even if I'm repeating it, it shows that you are alert and you guys are using your brains. Even if you got many hints from me, it's fine. Even if you made some mistake and you put a wrong answer, it is fine. Nobody will judge you here, nor will I, nor will any of the warriors here will judge you. Hello Pratik, hi Games Master, hello Minion, welcome aboard. So moving on to the next question, let's see how many of you can do this question as well. So what do we have over here? The angle of minimum deviation is equal to the angle of prism of an equilateral prism. The angle of incidence at which minimum deviation will be obtained is whole game of angles completely. So what do we know over here? That we have a equilateral prism. If it's an equilateral prism, this is 60 degrees. And for minimum deviation, obviously the ray should be parallel to the base. So the delta minimum is given to be the angle of prism. And since it is equilateral triangle, therefore that is also equal to 60 degrees. That's the first thing that we got. The next thing, the question says the angle of incidence for which minimum deviation will be obtained. So that means I1 is asked. Now since minimum deviation is given, isn't it obvious I1 and I2 are equal? But I don't know how much it is. I don't know. But I know they are equal. So now think, is there a formula relating deviation, angle of prism and incident angle? Is it Snell's law or something else? Yes, White Devil. If it is mentioned as retracing, the angle of incidence will be 0 or it is striking perpendicular to the mirror or that reflecting or the silvered surface, White Devil. Alright, so the formula that we will be using is delta minimum is equal to I1 plus I2 minus A. Delta minimum is 60, I1 I2 equal minus angle of prism also 60 degrees. So twice I1, 60 plus 60, 120. Therefore I1 is nothing but 60 degrees. That's the answer. Plain, simple, smooth. Medico goal, Pooja saying B. No, it is option A, bacha. It's okay, happens. Hi Sonalika, welcome back. Yep. You can by-heart the formula, but no need to by-heart such a formula. I know in some of the books that question is given as a variable. Alright, so no need to by-heart it as a formula, bacha. Yeah, that's all. Option A. It's just simple. Alright, because there are so many formulas then and so many questions with variables, you cannot sit and by-heart everything. Just remember the basics or else you'll get confused in the exam. Alright, wow, what do we have over here? Light is falling, spreading, and there you go. You get a rainbow-like beam. So why does this happen? And what is this phenomena called? This phenomena is called as the dispersion of light. What is this called? This is called dispersion. What is dispersion? It's basically the spreading of light or splitting of light into its constituent colors. White is not a color because white is made up of several colors. Your brain perceives the combination of these colors in the right amounts as white color. So technically speaking, white does not have a wavelength, it's a mixture of wavelengths. Keep this in mind. Now when such a mixed or an impure color is split into its individual components, alright, that is called as dispersion. Okay, what is that called? Dispersion. And why does light spread? The reason is simple. The refractive index for each and every wavelength is different. Red, orange, yellow, green, violet, blue, indigo, all these colors have different refractive index. Even infrared can bend, even ultraviolet can bend, but you cannot see it. So let's not talk about that. Remember, every wavelength has a different refractive index. So that's why you get the splitting up of colors, and you will notice that violet is the one which bends the most and red is the one which bends the least. So who has the highest refractive index? Who has the highest refractive index? Yes, like I said, invisible coder, the refractive index is different. Yep, for different wavelength. The wavelength is different, hence the refractive index is different. Understand the chronology. Understand the chronology, okay? Wavelength is different, that's why refractive index is different. That is why deviation is different. Every ray deviates differently. Logic should be clear. Violet, yes, it has highest refractive index of all the visible colors. And the order of the colors is very easy to remember. Remember the phrase Vibgyor, like over here, I can probably mark it. Vibgyor, okay? So there is one I also over here, that's missing. Violet, indigo blue, green, yellow, orange, red. That's the color scheme that you should remember. Yeah, Vibgyor, correct. Perfect, Pooja, perfect, everyone. All right. Now, there are certain terms which you should know. Very good, Dhanush. Excellente, minion. So there are some terms which you should know regarding the prisms. So like for example, if you talk about the, angular dispersion, what does this angular dispersion mean? It means if you have a thin prism, usually when we talk about dispersion, we usually are talking about thin prisms most of the time. You will see most of the questions are based on thin prism only. You will notice that this white light which entered in, it of course spreads, and violet spreads the most, or violet bends the most. This is your violet color, all right, and this is your red color. This has bent the least. Okay, so this angle that is there, this angle between them, this is called as the angular dispersion. You can also put the symbol delta theta over here. Delta theta is how much is the spread between the last two rays, or the first and the last ray. Okay, so the extreme rays, how much do they spread by? That is called as angular dispersion. Now that delta theta, simply put, is nothing but the deviation of the violet color minus the deviation of the red color. Deviation of violet minus deviation of red. And remember, for any color that you have, delta is A into mu minus 1. This is a very important formula which I have given you for thin prisms, of course. So hence, substituting that over here, what you get is nothing but, delta violet minus delta red will come out to be mu violet minus mu of red, and of course the angle of prism will come outside. Okay, so angle of prism will come outside. This is a very important formula. You can also remember the formula which is there over here. Either you remember this or remember this, it's one and the same thing. Everybody clear? Yeah, I hope this is clear. All right, great. Now, shall we move ahead to the next point? Okay, so difference between white light and monochromatic white light. There is nothing called as monochromatic white light. Okay, it doesn't make sense. White light can't be monochromatic. It's like an oxymoron. That means it's contradicting itself. No, white light is always a mixture of colors. Okay, so if the angle of incidence is such that it is more than the critical angle inside the prism, yes, it will get totally internally reflected. And yes, for different colors, the angle of critical angle will be different. Hence, some rays might come out, some rays may not come out. Okay, cool. All right. The next thing that you should know is something called as the dispersive power. The dispersive power, omega, is nothing but the angular dispersion upon the dispersion or the deviation of the mean color, or in this case yellow. Yellow is basically called as the mean color. Mean means average, is exactly the mid of the two extremes. So hence what you will get is over here as delta of violet minus delta of red divided by, you will get the deviation of yellow color. But if you again substitute everything in terms of refractive index, you will see the angle of prism gets cancelled and you will be left with only mu violet, okay, mu violet minus, just one second, mu violet minus mu of red divided by mu of yellow minus 1. This is what it will end up being. Okay, if you substitute each of these deltas in this form, remember refractive index is different for each color, so that's why I'm putting different refractive index. Also, one critical formula which everybody should know. So let me first of all block this very important formula right over here. Another important formula which everybody should know is that if you are given the refractive index of red color and violet color, the two extremes, the refractive index of yellow, since it is the average color, is actually the average. Meaning the refractive index of yellow is actually the refractive index of violet plus the refractive index of red, the whole thing divided by 2. This is another important formula which you should definitely know. It's actually the average color. So this is called as the average or mean color. Is that clear, everyone? Okay. So boards, hi bye, you are in 11th to 12th moving or 12th passing out. Okay, can we move ahead to the next one, guys? Okay, so let's move to combination of prism. Very important points being I will tell you over here regarding the combination. Now remember, prisms can be combined in multiple ways. These are prisms which are in opposite combination. They are not helping each other, they are opposing each other, because if this ray is getting split by this prism is collecting the rays and merging them. This is splitting, this is merging. So it's an opposite combination. If you turn this prism also upside down, so the rays which split here will further diverge, they will split and they will disperse even more. Now, sometimes you need to make sure that your prisms are opposite because you don't want the colors to split, especially your cameras, your lenses, alright? Over there, you don't want the colors to split, you want some combinations so that there is no deviation or there is no dispersion, and this is a whole ball game altogether, especially with all the camera manufacturers, phone manufacturers, because they want to make sure that the colors are pure, they do not get split, or else the red color from your body forms the image somewhere, the blue color forms the image somewhere, your image will definitely be blurred and it will not be crisp and sharp. So you need to do that. Alright, so what happens next is that we have two kinds of combination, and a lot of people always get confused. Sir, I don't know, sir, dispersion without deviation, deviation without dispersion, I get confused, sir. Okay, I'll tell you, it's a very easy thing to remember, and don't actually remember the formulas. I never tell my students to remember the formulas for this. You will see why, because it is confusing. Instead, remember the simple trick to write down the formula within 30 to 20 seconds. Just give me 20 seconds, I will tell you, within 20 seconds you can actually put that formula in your paper or your rough work while you are solving in the exam. Always concentrate on what is not happening. Dispersion, actually this is not from, this is without. This is dispersion without deviation. Two thin prisms are placed in contact such that the two reflecting angles are reversed with respect to each other. Actually, what it means is that there is no deviation. Now when I say no deviation, that means no deviation of the average color, The rays might deviate, maybe violet deviates, red deviates, but on an average there is no deviation, meaning the light which enters here spreads, converges, emerges, the final ray and the initial ray are parallel to each other. The final ray of yellow color is, parallel. I would say put a word parallel over here. Yes, parallel to the initial or incident ray for yellow color again. That means whatever deviation occurred for yellow color in the first prism is also the deviation of yellow color in the second prism, because if you rotate by 10 degrees and again rotate by 10 degrees in opposite directions, you have not deviated at all. So hence the deviation of yellow color in the first prism is the deviation of yellow color in the second prism. As simple as that. One will be, let's say, clockwise, the other will be counterclockwise. That's it. So net deviation is 0. Is that clear? That's all you need to know. And everybody knows what's the formula for deviation. A into mu minus 1. That's all. So you don't have to remember some complex formulas. Just remember this, that yes, the net deviation is 0. Concentrate on what is not happening. Here, there is no deviation. Hence, I can say that deviation in the first prism is countered by the deviation in the second prism. Hence, the net deviation is 0. Hence, the final ray and the incident ray are parallel. Okay, I hope this is clear. All right. Now the next, I think the diagrams got mismatched. Actually, this diagram should have come on the next slide and this diagram should have come on the previous slide, guys. Almost these rays look parallel. So ignore, understand the concept more than going completely into the diagram. Okay. So if you are moving from 11th to 12th, you can concentrate on your boards, but simultaneously make sure if you can watch the recorded classes, it will be better. That way you will save more time, high pi. Okay. So let's move on. Very good, Ishan. I'm pretty sure you will. So Yashika and others, I think a lot of you are asking suggestions for physics. Just hold on till the end of the class. I'll definitely help you out with what you should do regarding 11 to 12 standard students. Hold on. Towards the end, I'll chit chat with you. Okay. Let's focus on the concepts and problems now. Okay. Now what is not happening over here? Concentrate. What is not happening? Dispersion is not happening. Meaning whatever angle by which it spreads should be the angle by which it merges. Meaning the angle of dispersion in the first prism is the angle of prism in the second prism. The amount of spread is basically equal to the amount of convergence. How much ever it spreads, it converges by the same. Hence, there is no net splitting. That's what it means. Definitely, street boy. Why not? You have time. So, you know the formula for delta theta? I'll just go back a little bit. Look at this. I'll just go back a little bit. Delta theta. Either this or this. Use any one of them. For each prism, you get the answer. Will you sit and by heart A1 into mu V1 minus mu R2? No. Please don't do that. That is stupidity. A lot of people get confused whether it is one, yellow, red, whatever. Just remember the concept. I think now we are ready to solve some questions. I hope you guys are ready. Yep. Shall we start with some questions, guys? Here comes the first question on your screen right now. All right, there we go. Yes, Siddharth, you're a little bit late, but it's okay. Join in and start watching, at least from now. Watch the remaining part later on, the recorded version. Awesome, Ishan, Sri Krishnan. Have you done refraction through curved body? Yes, Vishnu Chintan. In my regular long-term batch, even on YouTube, I have done the curved surface refraction. It's there in the playlist. Also, in the one shot, I have done it. So it's there in both the places, in lecture 1 for 0 to superhero. Okay, so let's see how many of you can get this. When light enters from air to glass, which color the angle of deviation is maximum? This is obvious, come on. Yep, Dhanush saying D, Medigo saying D, Sri Krishnan saying D, Sonalika saying violet, Shruti saying A, okay. And most of you are going with violet? Yes, it is indeed violet. I just showed you over here right now. Look at this. violet spreads the most or deviates the most, red has least refractive index. So hence you will see that it will be the violet color which deviates the most. So if you have a glass slab like this, and if you notice that white light enters into this, you will see that violet will bend the most, and you will see that red will not bend so much, and yellow will be somewhere in between. Yellow, green will be somewhere in between. This is how it will look. Okay, cool. So moving on to the next one. When white light, definitely street ball, like I told you, Ishan, it's roughly for 1.5 hours to 2 hours because it's a big topic, and that's why I had to split it up into two lectures. When white light passes through a dispersive medium, it breaks into various colors. Which of the following statements is true? Come on, let's see how many of you can get this. Velocity of light for violet is greater than the velocity of light for red color. Velocity of light for violet is less than red. Velocity of light is same for all colors. Velocity of light for different colors has nothing to do with the phenomena of dispersion. Oh, Roshant, you can rewind back, but I would suggest you watch the current part. In case you find difficulty, then you can always go back even in a live class by scrolling the scroller of YouTube. Yeah, you have that option. Let's see how many of you can get this. Okay, Shruti, don't worry, bacha, happens. Mistakes do happen. Okay, Janani saying A, Dhanush saying A, Shruti saying B, Kavyasri saying violet, Donala saying A. Violet is not an option, bacha. I'm not sure what you mean. Okay, so B or A? Okay, a lot of you are confused. All right, or what about D and C? Nobody going with D and C? Let's see the final answer. Actually, it is B. This is not A. Very good, congratulations. So those of you got it right. So what happens is that we know that out of all the colors, violet has the highest refractive index. It has the highest refractive index. And we all know that the speed of light is nothing but the speed of light in vacuum divided by the refractive index. So if mu increases, the speed decreases. So in fact, all colors have different speeds in different medium or in the same medium also. So when all these colors enter glass or water, you will see that red will travel the fastest, violet will be the slowest. So hence the correct answer is velocity of violet is less than the velocity of red because refractive index is different, and we know refractive index decides your speed of light in a particular medium. Yep. I was born in 1758 or something, yeah, around that time. Just before, like when Britishers were coming around, yeah. Anyways, so dispersive power depends on the following: material of the prism, shape of the prism, size, shape, and material of the prism. Let's see how many of you can get this. Oh, where was I born? I was born, let me see, on land somewhere. Yes, I don't know, somewhere. Okay, so Vishnu Charitan, Ramesh, Dhanush, Kavyasri, everybody giving different answers. Antarctica, yeah. Today only I was watching a movie about Antarctica. Madagascar. I love those penguins. I wish I was born in Antarctica with penguins. No tension, right? No IIT, no NIT, no teaching, nothing. Chill out with penguins. Just laze around, eat some nuts, just save yourself from all the predators out there, and just roll in ice. Yeah, so cool. Literally. Okay, so let's see what it is going to be like. Yes, it was Salem. Okay, dispersive power depends on material of the prism. Material of the prism, guys. Okay. So, Arjun, I'll answer your question, bacha. Don't worry. Towards the end of the class, I'll chit chat with you. Okay, so the dispersive power. I just told you. Okay, if you want, I'll just go back. Don't believe, right? No problem. There we go. Dispersive power. This is dispersive power, omega. It depends on refractive indices only. Angle of prism gets cancelled from the numerator as well as the denominator. So angle of prism or the size has no role to play in this. Hence the correct answer is only refractive index. Material of the prism basically decides your refractive index. Nothing at all. All right, next question coming up on your screen. Thank you, Shruti, for all those cute penguins out there. Made my day. Okay, so a thin prism P of refractive angle 3 degrees and refractive index 1.5 is combined with another prism of refractive index something to produce dispersion without deviation. Everything else is nonsense. Just remember, you should see the words which is not happening. What is not happening? Deviation is not happening. And when deviation is not happening, it is not happening for the average or the mean color. Which is the average color? The color in which I have written these words, which is yellow. Alright, so the deviation of yellow color in the first prism, which happens in one direction, is equal to the deviation of yellow color in the second prism, which will happen in the exactly opposite direction, so that the net deviation is 0. Deviation of yellow color in the first prism is angle of the prism into refractive index of yellow color in the first prism minus 1, and deviation of yellow color in the second prism is again angle of prism into refractive index of yellow color for the different glass minus 1. Remember, same color will have different refractive index in different medium. Alright, so just substitute. A1 is nothing but 3. Mu of yellow in the first prism is 1.5, so minus 1. Angle of prism, I think I need to figure that out. Refractive index is 1.6, of course, minus 1. 1.5 minus 1 is 0.5, so this will be 3 into half is equal to A2. 1.6 minus 1 is 0.6, 0.6 is 6 by 10, 6 by 10 is 3 by 5, so into 3 by 5, 3 goes, so A2 will be nothing but 5 goes on the top, 2 stays below, 5 by 2 is nothing but 2.5 degrees, which is option D. Perfecto, that should be the answer. Yes, we got it right. Amazing. Yep, very good, very good. Priyanshu Negi, Acha, this is English channel. So we have a dedicated Hindi English channel where a lot of content is being taught in Hindi. But yes, the problems, everything are in English only. So the JEE Hindi channel is also there. And here we cater to all the English medium students who are in CBSE, ICSE or state board schools, but they are learning in English medium. But students who are comfortable in Hindi, they have multiple options as well. No, I don't know. I don't know. Okay, so option D. For the first prism, where the angle of prism is given, look at this. A thin prism of refracting angle. Refracting angle means A only. It's just a way of saying it. I hope this is clear. Okay, so Rupali, just watch my session which I conducted just some time back. So guys, all the 12th standard students, I'm guessing you have seen my session which I conducted few days back over here. Toppers 2 months complete routine for JEE, NEET as well as boards. So just watch this session guys, everything you will be clear. I have given everything what you should do before the exam, 2 days before the exam, few weeks before the exam, everything has been mentioned. So make sure you watch it. Alright bacha? Alright, let's move on to the next question coming up on your screen. And what do we have over here? Oh, the questions are over. I think we are going to the next topic. Alright, I don't know. Yes, I do remember you. Alright, yeah. Okay, so let's move on. Garima, watch it in 1.5x or 2x. Okay, watch the critical points at least, but watch it. But if you don't watch it, then you will miss it. Then you will waste more time, because you have not watched it. So it's better to use that time and watch it even at 2x speed and then make sure that you implement it. Now, we all know that our eye is also nothing but a lens. And the lens which is there in our eye is a miracle because it has a variable focal length. It also can change its size, basically its aperture, and decide how much light should enter in. Like when it is dark, then your eye widens up because it has to collect more light, because to form that image you need more rays. And when it is bright outside, automatically it contracts and you will see very little light enters your eye because that is sufficient to form the image. Also, it can focus on anything, and there are ciliary muscles inside your eye which relax or strain themselves, and automatically it happens that they focus on the object at which you are looking at. Not just that, you will see as you grow, there are a lot of defects which can occur, or also defects which can occur because you are straining your eyes too much, and that's why you need to have some corrective measures to make sure that the image is formed on the retina. Retina is the place where all the rays should form a crisp and clear image, and your optic nerve collects that data, sends it to the brain, processes it, and then gives you that movie which you are seeing right now. Alright, now the important thing that you should know over here is that usually the rays will merge, okay, at the retina. That's for a normal eye. Now when you bring an object closer, like you bring your hand, it becomes very difficult for the eyes to focus, because your eyes are under strain, because the focal length of the eye will change to make sure that the rays converge over here. And there is a point till which you can bring your hand or any object close. Beyond that, although you will be able to see it, but your eyes will not be able to see it so clearly. It will be blurred because the image is not perfectly formed on the retina. So that distance till which you can see things clearly is called as the least distance of distinct vision. What is it called? The least distance of distinct vision. Is that clear? Okay, when you bring the object closer to the eye, to maintain the distance, the focal length of the eye has to become very short, and this happens because of the strain exerted by the ciliary muscles. This is called as the accommodation, and D is small. Usually this value of D is 25 centimeters. This D is nothing but this D minimum. Generally you use the capital symbol. So let me use the same symbol right over here. Okay. So least distance of approximately 25 centimeter. For small babies who are in first standard, second standard and all that, it is very small. It is 8 centimeters, 9 centimeters. So as you grow, this D also increases. That's your natural process. Then the next concept that you should know is, oh my god, I think yeah, it's mentioned over here, but where did the other, yeah, I have put the ray diagram over here. I had put all the data points over here, like you can see. Now the next thing that you need to know is totally relaxed. Yeah, totally relaxed, meaning when you are looking at distant objects like a mountain or a cloud or the sky or the sunset or the horizon, then your eyes are very relaxed. You feel at peace. There is hardly any strain on the eye. But due to certain defects, sometimes it so happens that the farthest distance that you can see cannot or gets limited because your eyes can't be totally relaxed for some reason, or because of the odd shape of your eye, you are not able to focus a distant object. So a normal functioning human eye should have the farthest distance as infinity, meaning you should be able to see the stars in the sky clearly without any blurring effect. So that is a perfectly functioning human eye whose far point or whose farthest distance is infinity, meaning you can collect the rays and form the image on the retina under completely relaxed condition. Keep this in mind. Alright, now if these things are clear, let's move on. Remember, you can use lenses to correct both these defects. You can use lenses to correct. Okay, so I will show you some problems, because in JEE or NEET we do not have the biological part of it. Oh, what happens to these muscles? What is the shape of the eyeball? No, they will just give you questions like what should be the corrective measure, what kind of defect it is called, or what is the focal length, or what is the power of the lens to be used. We'll solve those problems in a bit. Okay, now magnifying glass. These are your optical instruments which we are going to study in today's class. So the first optical instrument is a simple microscope. It is also called as just a magnifying glass. Now see, when I say a magnifying glass or a simple microscope, it's nothing but a convex lens. Nothing more, nothing less. You all would have used convex lenses at some point of time. Maybe you can tell me what did you use it for. Okay, so and you would have also seen detectives use it because they are scanning for fingerprints. Okay, so usually what happens is that when you are using a convex lens, you make sure that the object is over here. This is the object, and the image which is formed, all right, is virtual. This is a virtual and enlarged image. That's what you will try to do. and you will try to keep it at least at least distance of distinct vision from your eye. So if this is your eye, you will try to make sure that at least this distance is D, because if the image is formed here, you cannot bring it closer because your eyes won't be able to focus it. But if the image goes far away, you will be able to see it, but it will be less magnified. Okay. Now, the most important things that you need to know before I go ahead is something called as the magnifying power. Many people get confused between magnifying power and magnification. How many of you know the difference between magnifying power and magnification? In lecture 1 of Ray Optics of Zero to Superhero, I've told you magnification is height of the image upon height of the object. But magnifying power of an optical instrument is completely different ball game. See, whenever you see an object, that object subtends some angle, on your eye. That is how much angle your object subtends on an eye. Okay, that is your perceived angle. No, it is not width. Okay, observe this now. So magnifying power of optical instrument is basically the angle subtended. Okay, I think I need to get rid of this now. I don't have space, sorry guys. But this diagram is there on the next slide, don't worry. The angle subtended with the instrument upon the angle subtended without the instrument at least distance of distinct vision. Meaning you bring the object closer, it looks big, but there is a maximum distance or minimum distance till which you can get it. Beyond this, it will not be clear. So it is subtending some angle now. Now you use the optical instrument, suddenly it becomes enlarged. Without the instrument, it is subtending, let's say 5 degrees. With the instrument, it subtends 10 degrees. So 10 degrees by 5 degrees is the magnifying power. No, there is no power in this. It's a blue filter. I hope you can see those blue things. It's a blue filter, guys. There is no power. It's just that I'm protecting my eyes from all the lights out here. I'm constantly in front of so many lights. That's all. Okay. So this is something which you should know. Now, this is how the ray diagrams look like. You can see the object is placed before the focal point and between the pole. You will see you will get an erect virtual magnified image right over here. And you have two adjustments, one for normal, one for least distance of distinct vision. When I say normal adjustment, what does it mean? Where is the image formed? Normal. That means your eyes are relaxed. So basically here your eyes are relaxed. That means where is the image formed? The image is formed at very large distance. Very far away, but it is very large. Then the magnifying power is just given by D by the focal length. That's all. But if you are keeping the image, if you are making sure that this image is formed at the least distance of distinct vision, then the magnifying power is given by 1 plus D by F. This is the only difference. That's it. 1 plus D by F. Here it is more, here it is less by 1. That's all. Is that clear, my warriors? Will you remember this formula? For sure? Yep. Shall we go to some questions? Okay. So here is your first question coming up on your screen now. When objects at different distances are seen by the eye, which of the following remains constant? Which of the following remains constant? Awesome, Sonalika, Shruti. Let's see if you can get this. When objects are placed at different distances, which of the following remains same. Come on, this is very straightforward. Very good, Shweta. Come on, guys, figure this out. It's not at all difficult. Shamira saying option A. Shruti saying option C. Okay. I'll tell you something. Okay. When you focus at different points, what happens? Your eye, I told you, is a miracle. It's an amazing lens. It adjusts itself, meaning it changes its focal length. And how do you change its focal length? Remember, your eye lens has a radius of curvature. The radius of curvature changes. And I hope you remember lens maker formula. 1 by f is mu minus 1, 1 by r1 minus 1 by r2. If you change r, you will notice that your focal length changes. So radius of curvature, no. Object, obviously object can be anywhere. It's not under your control. Focal length of the eye, that changes based on where the object is placed to ensure that the image is always formed on the retina. So always the distance between the image and the eye lens, alright, is the same. Option D is correct. No, it's not ABC. I just told you over here at the start, no matter what you do, the image is always being portrayed on the retina. So this lens will adjust itself. No matter what you do, it will always adjust itself. So distance between lens and this remains same. It will not change. The focal length adjusts itself. Focal length adjusts itself. Understood? Is this point clear, my warriors? It's a miracle. It's a beauty of the human body. It's what nature has made. All right. So let's move on to the next question. Radius will change. Focal length will change. Object distance will change. No matter what you do, you cannot keep it fixed. It will change. A person cannot see beyond 2 meters. What is the power of the lens? Oh, sorry. Not what is the power of the lens. What is he suffering from? What is he suffering from? What is he suffering from? He has myopia. He has presbyopia. He has corona. Oh my God. He has hypermetropia. Okay, come on guys. Let's see who are the doctors here. Some patient comes. Some Pandu comes. A Pandu patient comes and he is like, I cannot see properly beyond 2 meters. What is your diagnosis? Come on, future doctors. And engineers too can diagnose, I'm pretty sure. Does he have myopia? Does he have presbyopia? Does he have corona? Does he have hypermetropia? Or does he have loose motions? Okay. Come on, guys. Come on, all the future doctors. Please. Okay. D. Sure. He cannot see properly beyond 2 meters. Thank God, Stephen. A or D? Guys, okay. Have you heard this phrase that he has a myopic view? He has a myopic view on this topic. Meaning, he has a very short-sighted view. Meaning, he cannot think in the future. Like he's only thinking in the present. Like, let's say you have a friend and he's like, okay, I need to play games now. It's okay. Exams are around the corner. So, and he does not think too great about teachers or schools or education. He has a very narrow-minded, myopic view. So that's what it is. You cannot see things beyond. Myopia. Yes, that's what it is. It's myopia. Okay. So it's things which are close by. You can see what is happening around you, but you cannot think beyond. Myopic view. Is that now clear? Hi, Kriti. D sir to Pandu. No, my God, everybody. Who are these doctors? They will for sure give some different lens to that Pandu. Pandu will be like, oh my God, I came for myopia. You gave me glasses for hypermetropia. Now though I can't see things beyond even 10 centimeters. At least then I could see things beyond 2 meters. Now you gave me opposite lenses. Now gone. I can't see things even beyond 10 centimeters. So guys, be careful. You have to diagnose properly. Things start right from the basics. Old Roshant, it's okay, bacha. So don't worry. All the other students out here, Roshant, they are going to diagnose you. Okay, they are going to do very good diagnosis. Some students are going to tell you that you are having corona also, and they will put you into the government general ward. Yeah, in the corona center. Yeah, complete detention. That's it. Isolation, food, also you will get that standard dabba wala food then. Okay, a man can see clearly up to 3 meters. Come on guys, prescribe a lens for his spectacles so that he can see clearly up to 12 meters. Okay, you know how doctors will prescribe? Like this. Just kidding, just take it lightly, like this. That's it. This is the prescription, guys. Okay, so that is the answer. This is the solution. Please understand whatever it means. Okay, so but the chemist will understand this somehow. I don't know how. So this is a prescription, guys. Come on. So what is the solution? Come on, figure this out. Something that I would understand. Okay, so a man can see clearly up to 3 meters. So he can see clearly up to 3 meters, but you want to prescribe him some lens so that he can see up to 12 meters. So imagine some lens. If you put an object, over here, the image should be formed. The image should be formed at 3 meters because he cannot see beyond 3 meters. This is his eye. Even with that correction, the image, if it is formed here, then he can see it. So this object which is at 12 meters, the image should be formed at 3 meters. So using 1 by v minus 1 by u is equal to 1 by f. 1 by v, image distance is nothing but minus 12. Oh sorry, minus 3, my bad. Image distance is nothing but minus 3. Minus 1 by u. U is object distance, which is minus 12, is equal to 1 by f. Therefore, 1 by f is equal to minus minus plus. So 1 by 12 minus 1 by 3. Take LCM. So 1 by 12 common minus 4. So it is minus 3 by 12, which is minus 1 by 4. So this is nothing but your 1 by f. But we all know power is 1 by f. Therefore, power is nothing but 1 by f is minus 1 by 4 diopters. It was all in meters, so you don't have to convert it from centimeters to meters. Hence, the correct option is minus 1 by 4 diopters. Is my handwriting better, guys? My handwriting is better? Okay. You guys understood, right? Paracetamol. Minion suggested paracetamol. Guys, that's a universal medicine. Anything happens, you have fever, paracetamol. You have headache, paracetamol. You have loose motions, paracetamol. You have alpha variant, paracetamol. You have delta variant, paracetamol. You have Omicron, paracetamol. Hi sir, hello Gogster. My God, we changed bacha, long time. We are NLEETs now. Yeah, please change your search protocols. Alright, so that's the answer, option C. Moving on to the next question on your screen. A simple magnifying glass is used in such a way that an image is formed 25 centimeters away from the eye. In order to have 10 times magnification, the focal length should be approximately, that means some approximations should be done. Let's see. Hi Tejaswini, hello everyone. Okay, so, oh, you should do B Pharm. Yes, I think they have some nexus, Sri Krishnan, very true. B Pharma people with MBBS people, like only you will understand. Nobody else will understand. Engineers should not understand it. That's it. Or else gone. How will you get business then? Okay. So what is the question over here? The question is magnifying power is given. So I know the magnifying power. The magnifying power is 10 times. The focal length, I don't know. Least distance of distinct vision is 25. And the image is formed from, in order to, the focal length should be nearly. Usually, whenever you are using the lens, you use it such that your eyes are constrained or strained basically. It's not for relaxed, it's when your eyes are strained and basically you are watching it at least distance of distinct vision. So the magnifying power formula is nothing but 1 plus d by f. Okay, so what do we have over here? Magnifying power is nothing but 10 is equal to 1 plus d is 25, f I don't know, so 25 by f is equal to 9, so f is equal to 25 by 9. Now according to this, so by the way this is in centimeters, according to this we have to find the approximate nearby answer. So 25 by 9, can I say, I can't see any options close by, so can I say it's approximately 25 by 10, approximately. So this is nothing but 2.5 centimeter. 2.5 centimeter is approximately nothing but 25 millimeter. Hence, the approximate closest answer is 25 millimeters. I hope this is clear. Perfecto. Rudresh, I'll be starting in May, and number 1. Number 2, Rudresh, will be, remember, I have already conducted the entire 12th standard syllabus right from electrostatics till modern physics in a very detailed manner, still available to you in the beautiful playlist. Start watching from there. I won't be conducting detailed classes again because it's the same thing. Instead, I'll be doing different things like advanced questions, problem solving, techniques, shortcuts, revision, those kind of sessions which will support you with the existing classes which is there in my playlist. That's what I'm going to do. So Dhanush, I've just used bacha this formula. Where is that? Magnification formula. Magnifying power. So usually when you watch through magnifying glass, you want the highest magnifying power. So if it is not specified, you always assume that it is at the least distance of distinct vision. So use this formula 1 plus d by f. So I've used the same thing over here as well, like you can see. Now the final value of f, I got it as 25 by 9. But since it said nearly, I said 25 by 9 is roughly, 9 is close to 10. So 25 by 10, which is 2.5. Convert centimeters into millimeters multiplied by 10. That's it. I hope this is clear, Dhanushk. Is that fine, bacha? Yes, Anush. Yes, sorry, Sonalika. That's correct. Option C. All right, moving on to the next, and that's compound microscope and telescope. So we have come to the last part of the class. Oh, so I was thinking that the class will go till 2 hours. No, I don't think so. You guys are lucky and you guys are getting everything in one shot, guys. This is the best thing that can happen to you before your exams, before your boards, before your, JEE, NEET, CUET, KVPY, BITSAT, all these exams. So let's get started with the last part, and that's compound microscope. It's a combination of 2 lenses, and what happens is you will place your object over here. The lens which is closer to the object, it's small. It is called as the obviously objective, and this is where your eye is. So that is why it is called as the eye piece. You will see that the object will form a real inverted enlarged image. This is your intermediate image or somewhere over here, and this lens acts like a magnifying glass. Magnifying glass is the same thing which I just told you. This lens will act like the magnifying glass, whatever I've shown you over here. Just that the object is inverted now, so that even the image will be inverted. So basically the image which is formed becomes the object for the eyepiece, and that object should be between the focal point and the pole, so that the image is further enlarged, magnified over here. So you will notice that since this image will now become the object for the second lens, you will see you will get a enlarged image like this. This is your final image I2 for the eye. This is the process. This is the process. And in this process, you will notice that the magnifying power, very important formula, the magnifying power of a compound microscope is nothing but magnification of objective, very important, magnification of objective multiplied by magnifying power of the magnifying glass. Magnifying glass, basically I'm talking about eyepiece. Eyepiece is the magnifying glass. I just told you in the previous slide, it behaves like the magnifying glass. This is a product. So see what is happening. This object first gets magnified here, then again it gets magnified here. So basically the total magnification is the magnification of the object into the magnifying power of the magnifying glass. If you remember that, half of your problems will be solved. No, it is not difficult, Janani. If you have learned, Ray Optics as well as optical instruments from me, you can even watch my detailed classes which is there in the Pathfinder 12th standard beautiful detailed playlist. Watch it and also watch this lecture Trust me, after this, you will never face difficulty in these kind of problems. So when you have to write down the formula, again, there are two situations over here. One is for least distance of distinct region, like you can see over here. So in that case, the magnifying power, okay, the magnifying power comes out to be object distance by image distance by object distance into, so for least distance of distinct region, so 1 plus d by f. But remember, this is the formula of magnifying glass for eyepiece. So focal length of eyepiece will come over here. This is the focal length of eyepiece which will come over here, not the focal length of the objective. Remember, the eyepiece acts like the magnifying glass. But if the final image is formed very, very far, then the magnifying power comes out to be V0 by U0, and instead of 1 plus d by f, it will be just d by fe. That's it, d by fe. Is that clear? Is that clear, my warriors? Perfect. But most of the times, there is another beautiful assumption which holds true. Another beautiful assumption which holds true, and that is something which you should remember. The numerator, which is V0, the numerator which is V0, which is the image distance from the objective lens, is such that this intermediate image forms very close to the eyepiece. This image forms very close to the eyepiece, hence V0 roughly equals to the length of the microscope. This is your length of the microscope, the distance between the two lenses. V0 is roughly the length most of the times, and the object distance from the objective, is the focal length. Because you are close to the focal length, the rays almost become parallel and they form the image very far away, very close to the eyepiece. This is the assumption which is usually made, which you can substitute it over here. Yeah. So is that clear, bachalo? Obviously, I think I have made one video, but still, yes, I'll be doing more problem sessions, of course, in the days to come. Let's see if you can solve some questions on this. A compound microscope, the intermediate images. Come on, this everybody should spam and give the answer. In a compound microscope, so what is the nature of the intermediate image? Come on, try to do this question. Is it virtual, real, or is it inverted, erect? Is it magnified or reduced? This is very obvious. I just told you just some time back. Figure it out. Roshanth saying option C. Come on, my warriors, figure this out. Roshanth, very good, spammed. So he has spammed twice, very good. Now he's saying C. In electrostatics and fusion, sir, can I skip electric flux and Gauss law, or can I complete electrostatics? No, hypa, you should not skip it. It is a very important. It's a very important topic. Okay. So I'm not sure why your message was timed out. I'm just messaging the admin. This is not supposed to happen. Okay, option C or D? The correct answer is C. Real, inverted and magnified. It's not virtual. Be careful. It's not virtual. It's definitely not erect. Go to this diagram. I have told you. This was the object. This is the intermediate image. It's obviously inverted. It's also real. Okay, it's real because the rays are converging and it is enlarged. So this is the intermediate image. What about the final image? Okay, let's see how many of you can answer it. If instead of the word intermediate, final word was used, then what will your answer be? Come on, C for Capto. Thank you, Shweta. What will your answer be? Hi, Kaushik. What will your answer be? Yep, just think about it. Oh, where did we go? Then it will be virtual. Nah, it's not erect. It's not erect. It's still inverted. Final image is inverted as compared to the original object. Final image is still inverted as compared to the original object. It's inverted only. It's magnified, but it is virtual this time. So virtual, I don't think the options are there. So virtual, inverted, and it will be magnified. Correct. Very good, Medico goal. So look at this diagram. Things will be very clear. virtual, okay, because the rays appear to originate from this point, inverted as compared to the original object, and it is magnified. Yeah, perfect. Let's see the next question. In order to increase the magnification of a microscope, one should increase the object size, the aperture of the lens, the focal length of the lens, the power of the lens. These options are very funny. Hi Sham, Balangu. So imagine you are seeing through a microscope and you are watching some amoeba. This is that amoeba. Okay, this is the amoeba. It has some crazy things, right? This is the eyes of the amoeba. This is how the amoeba is. You are not able to see it properly. What will you do? You are going to feed the amoeba. What will you do? You will feed the amoeba so that the amoeba will become fat. Once the amoeba becomes fat, what happens is it will look like this. Then using a magnifying glass also, you will be able to see the amoeba. Correct? So that's how it is. So you are going to increase the object size. Hai na? No? No, right? Obviously not. How will you do that? How will you increase the object size? No. Aperture of the lens. Increasing the aperture of the lens will just make it more intense. It will just make it more intense because it will improve the lighting quality. More light rays will enter in. So it will not change the magnification. So this is also wrong. Focal length or power. If you increase the focal length, power will reduce. In fact, always focal lengths are in the denominator. If you notice all the formulas, focal length is denominator, U is focal length is again in the denominator. So if you reduce the focal length, magnifying power will increase. So hence the correct answer is D. So one will increase. If you increase the focal length, power will go down. Be careful. Is that understood? Very good. Perfecto. Simple. Amazing. Next question coming on your screen. All right. So microscope is having an objective focal length of 1 centimeter. I'll just write down whatever is known to me. Objective focal length, that means FO is 1 centimeter. Eyepiece focal length, FE is 6 centimeter. Then if the tube length is 30 centimeter, L is 30 centimeter. And the image is formed at the least distance of distinct vision. Image at least distance of distinct vision. And approximate magnification produced, D is 25 centimeters. And the question is, what is the magnifying power? Okay, so I think I know the formula of magnifying power. Let's use that. The magnifying power is nothing but V naught by U naught into 1 plus D by FE. I have also told you that this V naught over here is roughly the length in most of the cases, and this U naught over here is nothing but the focal length of the objective. That's how the approximations are. So use these approximations and see what do we get. The length of the tube is 30, so just put it over here. The focal length of the objective is 1 centimeter, so just put it over here. 1 plus D is nothing but 25. Focal length of the eyepiece is nothing but 6 over here. So this will become 30. Now 25 by 5. Now see guys, approximate. We have to make some approximations. So let's do an approximate calculation. I will put approximately 1 plus 25 by 5 roughly. I know 25 by 6 is smaller. 25 by 5 will give me slightly higher value. Something like that. 25 by 5 I know is nothing but 5. 5 plus 1? 5 plus 1? Yep. Okay. So guys, oh sorry, 25 by, I can do it 5. This is one catch guys. I think I made a wrong approximation. I should not do that. I'll teach you one trick. Very, very important thing which you will learn today. Should I approximate 25 by 6 as 25 by 5 or 24 by 6? Which is a better one? Thank you, Joel MJ. Which is a better one? This is a catch. Many people will get stuck over here. 25 by 5 or 24 by 6? Come on, let's see who can get this correct. Many students will get confused. 25 by 6 or 24 by 6? No, Priyanshu, there is a correct answer. Hold on. Somebody saying, sir, 25 by 5. No, guys, please don't do that. 25 by 5 is bad. Don't do that. Okay? Guys, when you have a small number in the denominator, and when you change the denominator from 6 to 5, you are going to get a much wider change, a much bigger change. So don't do that. Here, this is a big number. 25, 24, fine. So in a big number, if you take out 1, the result will not be affected so much. But from 6, if you take out 1, that is a big change. So from when you have 100 crore rupees, Anil Ambani has hundreds of crores of rupees. Somebody takes out 1,000 rupees. It's okay. No problem. 1,000, 1 crore, 100 crores I have. But if somebody has few thousands of rupees, you take out 1,000, that will be a big problem. So this is a better approximation, not this. Is that clear? Yes. Don't even have to find the value, but you should understand the psychology, the logic behind it. So this will be roughly 24 by 6. So this will then become 4. This will become 4. 1 plus 4 is 5. 5 into 30 is nothing but 150. Hence the correct answer will be 150. Very good. Excellent. Amazing. 25 by 5 will give me 5. 5 plus 1, 6. 6 into 30, 180. 180 is not even there in the answer. But if there is a cunning examiner who has fought with his wife just while he was making the paper, you don't know, right? What was the mood of the person making your question paper? He fought with his wife. He's very angry. He's very pissed. He's very, given up. He will decide, that's it. I'm going to take revenge. But he can't fight with his wife. So what he will do? He'll make a tough option. He'll put 180 also. He is very cruel. He knows kids will make some approximation, some blunder over here. Many students, 180, come on, let's mark it. So you don't have to fall in the trap. You don't know what is the mood of the examiner, the paper setter. You have to maintain your mood. Why? Because you have not fought with your wife. Why have you not fought with your wife? Because you don't have a wife. So chill, guys. So let's move to the next concept, and that is telescope. Mr. Knight, please watch the replay, bacha. Okay, just please watch the replay. Just use the formula. That's it. Everything was given. Tuck, 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 tuck. This approximation also I gave it to you right over here, bacha. Right over here. This over here. Just substitute everything. It's just there. Okay, you can do it. All right, moving to some telescope related problems. So, what are the uses of telescopes? What are the uses of telescopes? To watch stars, and Pandu told to watch Champa, who is in the girls' hostel. So 2 uses. Yeah, make sure you write both the pointers in the board exam. You will get full big 0. Okay. To zoom into distant objects. Okay, perfect. So in these cases, the object distance is roughly infinity, and you will notice that again the rays, or I can say the object is at infinity. The rays will come over here and they will form one image, intermediate image. This is intermediate image. This intermediate image will become the object for the next lens, and you will notice again an image is formed over here. This is I2. That's it, the final image. Your eyes are over here. That is why it is called as the eye piece, and this is closer to the object. That's why it is called as the objective. Again, this one over here is the distance between the objective lens and eyepiece lens. Both are separated by a distance of L. That is called as the length of the telescope. To watch Earth from the moon, yes, every day Roshan watches the Earth from the moon. It's very simple. Yeah, cool. So yeah sir, I'm going to tell. Viewing distant objects, very good, very good. Okay, so this is how the ray diagram is. You should know this from your board's perspective, of course, but the important formulas right now over here are, first of all, the length of the tube is FO plus FE. Basically this FO is roughly equal to the image distance from the objective. FE is basically the object distance for the eyepiece. So this is the approximate relationship which holds true for a telescope. That's something which you should know. And the next formula which you should know is the magnifying power, which is FO by FE. And you are always going to see the image very, very far away. Obviously, it's not like you are seeing the Jupiter or the moon. You're not going to see it here. Oh my God, least distance of distinct vision. That would be scary. Okay, so you're still going to see it far, but you're going to see it zoomed out. If the Jupiter was this small or the moon was this small, now you're going to see it stretched out. But even if it is far, it doesn't really matter. Okay, no, not much, Gautam. What is it all about? So alpha bars, this is one shot, bacha. So if you want any detailed concept, my playlist is there. I mean, I can just show it to you right over here. Some students don't know about it. Guys, everything I've done for you, it's just a matter of, are you seeing it or not? Zero to superhero playlist is there, obviously. Okay. If you notice, sprint sessions for problem solving is there. Zero to hero, physics, maths, mock tests, everything is there right over. Oops, what just happened? Okay, playlists, let me just go back. Yes, so all these playlists are there, okay? Right over here. Over here you will see JEE NEET class 12, maths, physics, chemistry. Notice this is view full playlist. If you click on this, right from electrostatics, each subtopic in detail has been taught right from electrostatics till the last chapter. Okay, I hope this is clear. All right, perfect. So let's start solving some questions based on telescope, and here comes the first question. The magnifying power or a telescope of a telescope is M. If the focal length of the eyepiece is halved, then the magnifying power will become twice, half. Is there a difference between these two? I don't think so. Okay, I don't know. Maybe, may not be. Let's see. 0% injury to human body while auto in an accident. Oh my God, that's scary. Or that's great. I mean, like, how is it even possible? Yeah, Arjun, you please put that message towards the end, or else I'll forget for sure. A for sure. Yeah, that's the correct answer, because the magnifying power is FO by FE. FE is in the denominator. Eyepiece is halved. This is made half times. Obviously, the magnification will become 2 times because this is there in the denominator. If it was there in the numerator, then it will also become half times. Moving on to the next question. For a telescope which has objective and eyepiece powers of 0.5 and 20D, what is the magnifying power? This is very simple. Just understand the trick. Trust me, you will get it. Come on, I want you guys to spam in the chat box. Don't worry, even if you're wrong, nobody is going to judge you, but you will feel happy that you attempted it. That attitude is very important. All right, Project Graham. I'll definitely watch it, Gautam. This looks interesting after the class, maybe. Okay. So, what do you guys think about this? Telescope's power of both the lenses are given. Magnifying power, I just told you, is FO by FE. But we all know power is inversely proportional to the focal length. That means if FO by FE is given, so power of eyepiece by power of objective will be exactly the same ratio as FO by FE. Just invert it because there is an inverse relationship. Now we just put the power of the eyepiece. So power of the eyepiece is 20 and the power of the objective is nothing but 0.5. So obviously it is 2 times of 20, which is 40, which is option C. Of course, that's correct. Amazing, Anthony, Roshant, Medico, IIT aspirant, Mr. Knight, Kavyasri, Gautam, Janani. Oops, made a mistake. But now I hope you got it correct. All right, moving on to the next question coming up on your screen, and here it is. The focal length and the objective and eyepiece are 204. What is the length of the telescope for normal adjustment? Normal adjustment is when basically your eyes are basically relaxed. Image is at infinity, which is usually the case with telescopes. So what should be the answer for this? Come on, let's see how many of you can get this. Come on, Dhanushk, be quick. Anthony saying option C. What about others? I don't know. Is it 196? Is it 204? Is it 250? Is it 225? Kavyashree saying B. Roshan saying B. Interestingo. Mr. Knight saying 250. Dhanush saying C. IT aspirant saying B. Guys, I just gave you the formula. Where were you guys? Look at this. Oh, there we go. Length is focal lengths addition. That's it. Just add them. You will get the answer. L is FO plus FE. FO is 200 plus 4. Second standard maths. 204. Some of you did 200 plus 40. That's why you got 2, or I don't know, 240 you should have got. But why did you get 250? It was not 210 plus 40. I don't know. Some mistake. 204 centimeters. Happens. That's how you will learn from your mistakes. Okay. So guys, remember, sometimes you know everything, but these small mistakes stop you from getting All India rank 1 or under 100 rank. So the only difference between, the top 1000 rank and the top 10,000 rank is not the knowledge. It's about how many mistakes you do. So Anthony, I'm pretty sure if you work on your mistakes, I'm pretty sure one day you will be, All India rank within 10 or 100. And I have full faith on all the students out here who are going to excel in their studies. And if you want to take any help for practice of papers, for your assignments, for revising the theory, for asking your doubts, we have the CBSE Term 2 crash course available only for 999 rupees. Original price was 10,000 rupees. Obviously use my discount coupon code, you will get the offer, of course. And if you want to prepare for JEE also or NEET, then we have again classes where even I am teaching. You have full-fledged chapters being covered along with individual chapter assignments, mock tests, All India rank prediction, both for JEE as well as NEET, along with doubt solving during the class with the 2-teacher model. And you get all the access to all the quality content till your last day of exam. Please keep that in mind. And this is just for 1,800 rupees. Where do you get all this stuff? Yes, it's all there in the description box. Like you can see right over here while you're watching this video. All you need to do is just go down and you will notice that there are so many links. JEE Mains crash course, NEET crash course, Term 2 crash course. So if you open on Term 2 crash course, there you go. You also get KVP by preparation for SX for all the 12th standard students. Along with this, just for 999, just click on buy complete course. You have saved the money. You get board practice papers, assignments just for your practice. You don't have to scramble all over the place over the internet searching for material. Same thing for NEET. You can see the NEET crash course is there, and with all the revision, all the concepts, entire 11th, 12th syllabus with mock tests and the doubt solving. And these are all interactive learning courses. You can see it's just for 1,800 rupees again when you use my coupon code. And the same thing is also there for the JEE crash course, like you can see over here, all 90 classes. And even if you have missed some class, don't worry, you can always watch the recorded classes after the class is over. Don't worry about missing anything. I would suggest you to start your preparation as soon as possible. So I'm so glad, Gautam, now these concepts are clear. I would say if you want to make it even more refined, even more crystal clear, watch my detailed class also of optical instruments if needed. Else, if you are able to solve the problems, no need. You can use that time for some other topic. All the best, Adinand. All the best. I'm pretty sure you're going to rock your Kerala Physics Board exam. And I'm so proud and so happy that in spite of having board exam, you came here. But I'm pretty sure this chapter was there for your board exam as well. So, Telugu Gamer, why are you feeling hopeless, bacha? Aren't we here? Aren't all the best teachers on YouTube, that too for all of you, all the students before the exam, for term 2 preparation, for JEE preparation? And did I not promise you that I am going to also help you with your boards whenever it's going to happen? Alright, so we are going to conduct board marathons. Please watch all the detailed classes. It's there. Just make use of it. And if you feel that you're not performing well, make use of the crash course, because that will give you confidence and that will keep you in the competition. Every class has leaderboard, quizzes that will keep you on the edge. Okay, I have to perform. Okay, you have something to look forward to, or else you're just aimlessly working, but you don't know whether you're going right or not. So when you have certain things to test you every week, that's when you will feel motivated. You will forget about other things because you will not have time only for other things. Tomorrow's I will be conducting special sessions. I'm planning to record a video also for something very interesting. Okay, I'll not tell you. I'm going to put it up, which will be helpful for all 11th, 10th and for generations to come, including the existing 12th passing out or even the dropper students. So it's taking some time, but hopefully it will be up. But tomorrow at 8:30 I'll be coming for all the NEET students for the Ekalavya batch, how to prepare and how to actually score really high in NEET Physics, biology and all other topics as well. I'm going to come with an expert, Vipul sir. Yeah. Thank you, Mr. Knight. IIT aspirant, by watching all the one shots, definitely your percentiles are going to improve by a lot. Definitely, I can guarantee you, because last year when I conducted Zero to Hero, many heroes came out of it, and when they started attending more of my classes, I mean, although the series was not called Superhero, it truly became superheroes. There's been so many stories where students have watched our classes. They were, in tens and thousands of ranks. They got in thousands of ranks. Some of them even got 3-digit ranks from tens of thousands. So drastic improvements, through all the crash course and the YouTube material, which I'm very happy. So IT aspirant, tomorrow is a general, guidance session for all the NEET students. Plus tomorrow, if I'm able to complete, I'll put up the recorded video as well, mostly on electrostatics. Okay. So I hope that's all fine. And in case some of you had doubts, please let me know. And Kavyasri, I'm very happy, bacha. And guys, do not forget to change your display picture also. The link in the description box. You can change it to our Warrior Ninja, which shows your immense love, support to me as well as the channel. It means a lot. Also, I can see you in the chat box very distinctly and vividly when I see the logo, okay, of your YouTube display picture. Thank you so much, guys. That's it from my side. Have a great dinner. Stay safe, stay well, and keep coming to my classes. Bye-bye. Have a great time. This was Captain Sreyas signing off. Hasta la vista.